the agenda for today? What are we talking about?
We're going to be talking about acceleration now.
Acceleration.
Right.
Okay.
Something near and dear to my heart because I love cars.
Do you?
Yes.
Okay. Well, I have an equation for acceleration.
Yes. So what does this mean? We've got an A. What does that A mean?
A stands for acceleration.
Okay. What unit do we use for acceleration?
There's different ones, but most common you'll see in physics is meters per second squared.
Okay.
Okay.
Then we've got a delta V. What is that?
Well, the delta is this triangle thing,
Mm-hmm.
and that just means change. So I'll show you how to do that in a second.
Okay.
But the V we learned before is velocity,
Right.
and that's in meters per second.
Okay.
And then I bet you got T.
T is time.
T is time, and usually we do that in seconds, but you could use minutes or hours. That's okay too.
Right.
Okay, for this delta thing, it's the change. So it's like what it is over time. So like, for instance, if it's applies to that velocity right there. So to find that delta V, you take the V final, which is like at the end,
Mm-hmm.
and you subtract what it was in the beginning, and we call that initial, the initial.
Right.
Okay, so there's a little subtraction you have to do before you divide it.
Mm-hmm.
But we'll figure that out when we do some problems.
Okay.
Okay. So here I have my acceleration. Now, do you think acceleration is a vector or a scalar?
Well, is there a direction to it?
There is actually a direction.
Okay.
So which one is it? Do you remember?
Then it's going to be a vector.
Vector. Yeah, so that's going to be a vector. And anytime you change direction, even if you're going the same speed, you're changing your acceleration. So
Right.
if that changes, you've got acceleration going on.
That makes sense.
All right. So another kind of weird thing about acceleration is you can have negative acceleration, and it just means like what direction it's going into. So like here we have our cars. Let's say this car has a velocity in that positive direction,
Mm-hmm.
and it's also got an acceleration in that direction. That's going to be speeding up.
Okay.
Okay. But what's kind of weird is if you have a velocity going to the left and the acceleration going to the left, that's also speeding up.
Okay.
So they just have to match. They have to be going in the same direction.
So why aren't both of these positive then?
Because we just label one direction positive and one negative.
Okay.
It's directional.
So it's like this car here is going east and this one's going west. So since they're going in opposite directions, one's positive and one's negative.
Right. We just kind of decide. Usually positive goes on the right just because that's how everybody does it.
Right.
Okay, so now let me show you some different cars. Let's say that this guy is going this direction, so that's his velocity,
Mm-hmm.
but his acceleration is going that way. What do you think he's doing?
Got to be slowing down then.
Mm-hmm. Yeah, he's slowing down. But again, it's directional. So you'll notice these are not matching in their directions, and that's what makes that happen. So here, let's say this guy's velocity is going to the left, but his acceleration is going to the right.
So that guy is going to have a negative velocity but a positive acceleration and slowing down.
Right, and that's a little
Okay.
confusing because the acceleration is positive.
Right.
But that's how that works.
Okay.
Anderson, let's do one more guided practice. Okay.
Okay.
All right. Let's look at number 2. So Mark is traveling at 50 kilometers an hour. I'm going to write that down because that's one of my givens. And then he speeds up to a speed of 95 kilometers per hour. That's interesting. 2 of these kilometers per hour. And a time period of 22 seconds. What was his acceleration? Okay. I know seconds is time.
Mm-hmm.
Why do I have 2 of these? Kilometers an hour.
We've got an initial and we've got a final. So
Initial is like at the beginning?
initially, beginning.
Okay. And that's a velocity though, right?
Correct.
And then this is after, so that's the final.
Correct.
And it says, what is his acceleration? So there's my givens, and then the acceleration is going to be
Are unknown.
our unknown. Okay. So I have this equation. It has A, V, and T in it. And the delta, if I remember, that was change.
Yes, change
Right.
them.
Okay, so how do I find that?
You're going to need to subtract.
Okay.
It's your final minus your initial.
Okay. So I'm going to do 95 minus 50.
Yes, ma'am.
Okay, and that is going to give me
45.
45. And so that's my delta V.
Right.
I'm looking for A, and T was 22 seconds. I'm going to divide that out, and I get 2.05 kilometers per hour per second.
There you go.
All right. You have a different way?
Plug in the magic triangle.
Oh, the magic triangle. We still need our givens, our unknown, and our equation, right?
Correct.
And we actually still need to do this first.
You still need to know your delta V.
Okay. So this was 45. Okay. So now I'm going to take my triangle.
Delta V is on top in your equation, so it stays on top in the triangle.
Okay. And then A and T go below. Can plug in 45, 22, and it's on top of each other, so I
You divide.
divide. Okay. And so I'm going to get the same answer as if you did the algebra. Either strategy should get you the same answer.